Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see super heterodyne receiver. In this video we will see the working principle of super heterodyne receiver and the important features of it. So before starting with super heterodyne receiver, we have already saw different receivers in previous videos. I've explained the basic concepts of receiver, the basic parameters of the receiver. I would recommend you people to go through those videos so that you can understand this video very clearly. To start with super heterodyne receiver, first you got to understand why it is named as super heterodyne receiver, right? So it works in the principles of heterodyning. So what is heterodyning? That is here in super heterodyne receiver, what we will do is we will mix two different frequencies. That is, two different frequencies will be mixed together and it produces a third frequency which is a different frequency. This process is called heterodyning. So this super heterodyne receiver works in this principle of heterodyning. That is, it mixes two different frequency and produces a different frequency, right? That is why it is called as heterodyne receiver. And before going in depth about a super heterodyne receiver, I already said in the receiving section in the receiver, any particular signal basically it will be converted to an intermediate frequency and then we will direct the original signal that has been transmitted at the receiving at the transmitting side, right? So first you got to understand this principle, that is, in order of communication, signal processing, right, at higher frequency. Signal processing at higher frequency is difficult. Signal processing at higher frequency is difficult. Difficult in the sense we need higher caste. That is, caste will be high, and similarly we need sophisticated filters and elements to process the high frequency signal, right? And similarly, you want to understand processing a signal is different from transmitting a signal, right? So what I have said is processing the high frequency signal is a bit difficult because the cost will be very high, right? And similarly, transmitting a low frequency signal, that is, transmitting a low frequency signal will require more cost. That's because when you transmit a low frequency signal, we need a very small antenna, right? The size of the antenna will be very small and the bandwidth also very less. So depending upon the antenna less, right, and it will be little bit complex to transmit a low frequency signal, right? So transmitting a low frequency signal needs more cost and compared to high frequency signal. And that is why signal transmission will always happen at high frequency, and whereas signal processing will be done at the receiving side, which will be at the low frequency, right? Just for an introduction to understand the basic thing. And with this basic, you can understand the receiver working. I already discussed about different receivers. Here we will see the working principle of super heterodyne receiver. And as I said, remember these 2 points. That is, signal processing at will be convenient at lower frequencies, and similarly signal transmission will be convenient at higher frequencies, right? So with this basics, we will see the working principle of super heterodyne receiver. And as I said before, super heterodyne receiver is most predominantly used RF receiver. And the working principle is it works with the principle of heterodyning. That is, it converts the received signal to an intermediate frequency, and from that intermediate frequency, the original signal is detected, right? So you can see this is the basic block diagram of super heterodyne receiver, where the received signal, the signal will be received from the antenna, where that signal will be an normal RF signal, and it will be band limited by BPF. That is, we already seen in previous receiver, any particular signal which is received at the receiver, it will be tuned to a particular frequency. That is, it will be a tuning circuit or BPF. Here we will have BPF where it will remove the unwanted noise signal and it will be tuning the received signal to a particular frequency. right? And the received signal will be a weaker signal, so it will be amplified by using RF amplifier. Until here we have the RF signal. Till here we have RF signal. That is the signal with the frequency of RF. Right now, in super-attenuated receiver, as I said, any particular signal which is received will be converted to an intermediate frequency, that is to a lower frequency, that is a moderate frequency, by using a mixer. Here we use a mixer and a local oscillator signal, and this local oscillator signal will generate a particular signal at a particular frequency which is called as FOSC, that is local oscillator frequency signal, right? And this FOSC signal will be mixed with the RF signal and it will produce the intermediate frequency signal, that is FF. You want to understand here, I have said previously, any signal processing at the receiving side will be done using the lower frequencies, because processing the lower frequency signal is very comfortable. We can able to detect the original signal and also the cost will be very less, right? That is, whenever you mix this low oscillator signal and the RF signal, you'll get two different types of frequency that is possible. That is FRF plus FOSC and similarly FRF minus FOSC. Mixers can generate two different frequencies, right? But out of this, only this particular signal will be selected. That is, we have IF bandpass filter, which will reject all other frequencies and select only this particular frequency, because as I said, in all the receivers, we will use only the low frequency signals. So here we are selecting this particular signal by using IF bandpass filter, and all other signals will be rejected. Right? And this particular signal will be amplified and then it is given to the detector, that is demodulator, where we will detect the original signal, right? Original transmitted baseband signal, right? And that original baseband signal can be an analog or as well as digital. That is, we use a signal conditioning, right? And this signal conditioning uh, can be used both in either analog and as well as a digital data. If it is digital data, this signal conditioning, what it will do is it will convert this baseband signal to a digital signal. And when it is analog signal, this signal conditioning will be like it will be using an expander. You will use an expander because at the transmitting side you would have compressed the signal, and at the receiving side you will be using an expander, and we will use the obtained signal, that is the original signal. Right? This is the working of super heterodyne receiver. Right? So whatever I said, that is what explained in points here. You can see the antenna is followed by the VPF, which will be tuned to a particular frequency, and then you will use a local oscillator signal to obtain the intermediate frequency, and that intermediate frequency is band pass, and then we will select only the low frequency, because in any VHF and high frequency receivers, you will select only low frequency signal, and this higher signal which is obtained, right? This IF signal which we obtained will be having all the characteristics of the same RF signal. The only difference is there will be a shift in frequency. Here it is RF frequency, here it is changed to IF frequency, but the characteristics will be same, right? And this is the working of super heterodyne receiver, but you got to understand the very important theory of super heterodyne receiver, that is image frequency rejection. Image frequency rejection. Image frequency rejection. As I said, that is, we have an intermediate frequency here, right? And this intermediate frequency, right, it will be amplified, and then from that we will be detected the original signal. And if needed, we can also use another filter after this detector, that is demodulator. We can use a low pass filter which will remove the additional noise, right? So that we can have a very clear signal before it is sent to the conditioning, right? This is just an optional part. And as I said, the signal conditioning can be used in both analog and as well as digital. Whereas in digital, it will be used to convert to binary levels, and also in analog, we will use an expander, so that in the transmitting side, we will be using signal compression, whereas in the receiving side, we will use an expander, right? And the important theory of super heterodyne is image frequency rejection. And for that image frequency rejection, the first thing you want to understand here is the IF bandpass filter. This IF bandpass filter has to be very narrower, right? The bandwidth has to be very narrower so that it will reduce the noise, right? And but very important thing is if this has to be very narrow, if this has to be very narrow, then this higher frequency has to be very low. This higher frequency has to be very low. If this highest frequency has to be very low, then this local oscillator signal has to be in such a way that it has to be very close to the RF frequency. Understand this point very clearly. That is, if the IF frequency, IF bandpass filter has to have a narrow bandwidth, then this IF frequency has to be very low. And if this IF frequency has to be very low, then we have to use the local oscillator signal. That local oscillator has to be in the same frequency as that of the RF signal which is received, right? And because of this, there are chances that image frequency can happen. What is image frequency? Right? That is, we know that whatever signal which is received from the transmitter, that is the received signal will be converted to the intermediate frequency, right? And there are chances that even if there is a different signal which is received, different frequency which is received, it can produce a same RF IF signal, same intermediate frequency signal, which is nothing but the image frequency, right? So this image frequency has to be rejected. If not, what it will happen is it will create interference with the received signal, right? So it is very important that the filters, the bandpass filter which we use, has to remove this particular IF frequency, right? So this bandpass filter which is used at the input side, that is at the initial stage, has to remove this particular image frequency, and also it should remove the noise, unwanted noise which is coming from the signal, and the noise due to this RF amplifier. All these things has to be limited by this bandpass filter. Otherwise, this noise will interfere with this particular IF frequency, and what will happen is it will reduce the signal to noise ratio and it will degrade the performance of the super heterodyne receiver. So it is very important that we have to choose the bandpass filter, the IF filter, in such a way that it rejects all other unwanted frequency, including the image frequency, right? So that is what explained here. And similarly, another important point is, in order to reduce the image frequencies and to obtain low IF filtering, we can have different versions of super heterodyne receiver. That is, so far what this particular operation is the basic version of super heterodyne receiver. And if we need good image rejection frequencies and also low IF effective filtering, we can go for double conversion or triple conversion receiver. That is by using two mixer or triple mixer in order to obtain a good response for image frequencies, right? So this is the complete working of super heterodyne receiver. And as I said, it is the function of input BPF to reject the undesired image frequency. To reduce the input noise at the image frequency, including the circuit noise RF amplifier, image frequency BPF should be included between the RF amplifier and the mixer, right? That is, if you want to have a better performance, a better image frequency rejection, then we can include another particular filter, that is image frequency BPF, between this RF amplifier and the mixer, right? Similarly, we can have another low pass filter at this particular stage where we can also remove the unwanted noise. And as I said, this image frequency can be image frequency rejection can be improved by using dual conversion or triple conversion. That is, in dual conversion, we will have a first mixture and with a high IF, and similarly, we will have a second mixture with at low IF, right, which will have effective filtering. The IF frequency should be chosen according to the image rejection and filtering, but normally it is chosen depending upon the standard BPF and frequency determining components which is readily available, right? For example, the two common IF frequencies are 455 kilohertz and 10.7 megahertz for AM and FM broadcasts, right? So this is the complete working of super heterodyne receiver, where here you have to understand the basic principle and you have to explain about the image frequency rejection, right? And the reason why we choose low frequency as an intermediate frequency, right? So today what we have seen is we have seen the complete working of super heterodyne receiver. I believe this video will be very useful for you. Thank you, my dear students.